Hey everyone, my name is Brian Rosensteel. I'm with Wiz, specifically on the PMM team, and typically I handle public sector. But occasionally I get the pleasure of being able to talk a little bit about Zero Trust. And I'm excited to be able to do that today. And specifically, I'm very excited to talk about in ways that we can actually achieve Zero Trust, which is funny to say, especially after, 5, 10 years of nonstop barrage of buzzwords around, Zero Trust architecture or ZTA. But really, I'll kind of talk about some of the false starts that we've had, some of the ways that we've built kind of silo pillars of Zero Trust, and the way that we can, achieve that unified security vision that really was at the heart and what drove a lot of these Zero Trust conversations from the beginning. Now, speaking of beginnings, one of the things that I always love to do anytime I talk about Zero Trust is to start with this image. So this is a really kind of fun history lesson. Some people, you might immediately recognize this. Others, it might look a little familiar, but maybe a little bit strange. This is a picture of the ENIAC, which is seen as the first Turing complete computer. So Turing complete, even though that there were machines that were created before this, including the one by Alan Turing himself, that was used to help break Enigma. The first Turing complete computer, ENIAC, is really seen as the first modern computer. And I like to start with this because there are so many things that we could learn. In fact, I could spend all the time that I actually have just on this image, but I won't. But you'll notice in here, from a security perspective, they're able to go in, literally walk down the aisle and count, okay, how many wires, how many vacuum tubes, right? They're going to have complete visibility over the networking, complete visibility over the devices in play, as well as what's being run from an application standpoint. In fact, fun fact, some of those early applications are actually still classified to this day. And they understand everyone that's actually walked in, the ladies who actually operated this computer, everything, all the way up and down the line. Truly, that world of computing at that time was encapsulated within that brick and mortar. So that brick and mortar security was a real thing at that moment in time. That's vastly different from the world we live in today. So we take this complete understanding of what's going on from an IT perspective, and we contrast it with this image. Now, this is a picture of a data center, right? So I'll be surprised if you actually know which data center this is. You might, but likely not, because the data centers look very similar, especially from the air. I chose this particular image for two reasons. One, I've actually been inside of it, I've done work inside of it, which is fun. And two, I pass it quite often when, I drive from my home in Virginia and I head up towards Washington, D.C., which I do on a fairly regular basis. What's different here is this is just a data center in really a sea of data centers that exist today. We think about the fundamental difference around before, where IT was self-contained within a single building. We're not even self-contained within a single data center anymore. There's regional data centers. Think of things like AWS East versus West. It is a group of data centers where you're not even sure where your workloads are running per se, because it's more of this integrated mesh just from a resiliency, from a high availability standpoint. We have fundamentally shifted in major ways from where we once operated. And unfortunately, security really hasn't kept up, and it hasn't been able to grasp this, back-end infrastructure change that has so dominated what we've done from a modernization standpoint over the same time, maybe slightly earlier than really when Zero Trust came into the realm. I want you to think about that as we look at kind of this classic example of, CISA's 5 pillars of Zero Trust, of identity and device and networking and environments, application workloads, and data. And then think about that when we think about the challenges that cloud has brought in. Our traditional security models, how do they measure up? How do they deal with these changes where we don't even have a full grasp of the infrastructure underneath from a physical perspective? Cloud truly has changed everything, with very different environments that we have to be able to gain visibility for. Very different risks themselves, and very different models bringing in noise from a risk perspective, and very different ownership. So previously, we knew the individuals. We can go all the way back to the ENIAC and talk about the team of individuals who were responsible for programming that machine. Now, our ownership models are very spread, kind of a diverse perspective across our organization, and that's a good thing. But it means I don't have one centralized team that's managing everything. So we're hoping people follow the right procedure. We're hoping people install the various components that they need to so that I can gain visibility and be able to manage accordingly from a security perspective. But many times that gets missed, and we get shadow AI and shadow IT and lots of visibility gaps. But there's something else that cloud has changed, even more fundamental, and it's development. think about the difference of what it means to run a workload in a cloud environment versus previous. So when I think back to my time within government, where we would go through, we would say, okay, we're going to be developing this new application, or this is when applications were known as applications and not apps. And we would need to, or we were going to update to the next latest version. We did a lot of testing behind the scenes within sandbox environments, and we'd get deployed within a directory structure, right? Everything was very self-contained. It was very segmented as it went through the software development lifecycle. Now that lifecycle is truly continuous in a horizontal nature, where we are deploying snippets of code that are going to leverage microservices that are already deployed and already running. It is this horizontal nature that I think is the biggest disruption from a security perspective, but also one of the greatest enablement that cloud brings. Unfortunately, attackers are also viewing things in a horizontal nature. They don't really care about an org structure. I mean, they might a little bit, in so that they'll know how our SOC teams might be measured or our dev teams might be measured from a performance perspective, and they will actually use that against us. But overall, in this case, I've got an external attacker. I want to see where there's some sort of exposure, and I want to walk through the environment. I'm going to see, okay, where's our misconfiguration within networking? What does that expose from a workload perspective? Where am I able to get access to from an identity perspective? Can I elevate those permissions? Can I move laterally over to a database where there's sensitive information? That's how they view our organizational structure. But it's not how we have been built from a security perspective. We tend to have different teams who will focus within the code and pipeline and cloud and runtime. They'll have their own security tools. They'll do their own scanning. But because everything's deployed horizontally, we're actually scanning the same thing multiple times. We end up creating multiple different alerts. And we know that we need to resolve this. And so we've had different kind of stutter-start efforts to understand that context of how things connect together. From a zero trust perspective, we say, well, the zero trust team will be responsible for understanding, right? Or it's going to be the dev team or this other security team. But we don't have that broader understanding from a contextual standpoint of how things connect together, where we have duplication. And we end up really struggling to prioritize and understand true risk in the environment. So we have to have a different model. We have to have something where we're operating from a unified scanning and policy engine with shared code, cloud, and runtime context. We see these elements actually built into a lot of the core from a zero trust perspective. So if you go into special publication 800-207, you'll hear about things from the control plane and from the PEP and PDPs and all those other lovely acronyms. But the reality, if we go back and we pick on this model here, is what we said is, okay, we need to implement zero trust. We need that unified security. This is great. This is what we've been missing. Identity team, do a gap analysis. Figure out where we need to procure something, if we need to procure something, or what we need to change to become zero trust compliant. Networking team, do the same. Okay, you need microsegmentation, or go out and buy something that does microsegmentation. Data team, what do you need? So we went to the different teams, and we ended up procuring based upon various criteria that we viewed as critical for zero trust, and we procured in isolation. And what we ended up building were the 5 silos of zero trust. And we know that they're siloed. I've talked with various organizations. I say, okay, well, what do you see? What do you need? Where are you trying to invest? And many of them are turning to things like AI. We're saying, well, I'm hoping AI will actually be able to connect all of my different zero trust pillars together. In many ways, it makes me a little bit disheartened. I'm not overly surprised and a little bit concerned, because what they have done is kind of in the unfair way of what I've misled you to. They've looked at zero trust upon this particular image from a model perspective. Now, CISA never designed zero trust to be this way. And we know they didn't, because there's actually something that's missing here. And some of you may have caught it. Others may not have. There are 3 foundational steps: visibility, analytics, automation, orchestration, and governance. These were cross-functional, cross-foundational steps that CISA had put in to make sure we never had silos, where we were supposed to operate upon these models first, and then use that to gain information in the different concentrated areas for identity and data and network, et cetera. Where we've got visibility, we're automating in analysis, and we have a governance model to make sure that we are aligning from a particular type of risk model perspective, et cetera. When you build on that foundation, that's when you get a lot of agility, right? Especially within cloud environments where we have so many challenges. Now, and I always hesitate to even show these models in general, because people tend to look at them and they always focus up on those pillars. In my mind, if you really want to look at a better model from CISA, look at this one. This is actually an excerpt from their maturity model version 2 from page 10. It's figure 4. And you notice it's an eye chart, right? As most things are that come out of the US government, but it's meant to be far more integrated across, where every step along the way, as you move from like the traditional kind of legacy models where things are very fragmented, things are very manually intensive, up to the optimal state where we have continuous visibility and validation, automated analysis that's going on, and connecting the different areas together. All along the way, we have these cross-functional elements. So, hopefully your organization has really built upon these different cross-functional steps. But if you're struggling from a zero trust adoption perspective, you might want to look back in and say, are we getting the core fundamentals correct? Are we built for really the best practice that's inside of zero trust? And we always say zero trust isn't an actual thing to buy. It is a set of best practices. You can't just install it next to the water cooler. But it's a defense in depth strategy that starts with visibility and context. That's what enables you to build in prevention, detection, response, and more importantly, enables you to centralize security across your organization, across different teams. That's what we really mean from a democratized security standpoint. That's fundamental. People always talk about the cultural barriers for zero trust. Well, those cultural barriers come from building out silos instead of starting from a unified context that then is able to work out accordingly, and give that unified context out so that I know how to prioritize effectively. Let's drill in a little bit to make that make a little bit more sense. So in a modern kind of security operating model, what we see here, and this is really what Wiz has been so focused on trying to build, is we have at the core a unified policy framework. From Wiz perspective, we really do this from a graph database, but it's meant to incorporate in lots of signal, lots of information across the core areas from a software development standpoint, right? From a lifecycle standpoint, code, cloud, and what you're doing from like a defend or like an active cyber defense standpoint. Or we're going to pull in information across all of our different areas, across network, across devices, across workloads, across data, understand what vulnerabilities are out there, misconfigurations are out there, where there's potential of lateral movement from an identity perspective, et cetera. That information comes down with that cross-functional context. It allows us to disseminate this information to different teams. So I need to remediate. I need to reduce my overall attack surface. And I can do that by sending the right information over with that context to the relevant team. So as an example, my dev teams are constantly getting inundated with requests for updating various parts of the code, but you can tell them, hey, I need you to remediate this particular misconfiguration and vulnerability first, because what it's actually exposing is this other part of the organization, even though you didn't directly intend it to. What we end up doing is giving them the information behind what truly is a risk. So definition of risk, and I actually really like this definition. This actually comes from something from the US government within something called OMB A130. It's risk becomes a function of the potential for impact or harm against the likelihood of occurrence. And that's what risk is. That's something that I think is at the core even of what we're trying to do from a zero trust perspective. Let's understand where the greatest potential for harm for the organization is that has a really strong likelihood of occurring, and that's where we should be focused our efforts first. Let's get that type of information over to our source code owners and say, this is why we're asking you to fix this first. And let's make sure that context is in play when we're going across our different data security, cloud security teams, so that they know we are effectively prioritizing remediation, and it ultimately drives real impact, real benefit from a security perspective. Now, risk reduction isn't in just one area. It's typically something that you're going to achieve through three kind of not necessarily distinct areas, but distinct purposes. So you ask me, okay, where do I start for risk reduction? How do I achieve this across, everything from the diverse, the lifecycle from code to cloud to runtime? I always say start with proactive security. So you'll hear this talked a lot about continuous monitoring or ConMon, but it's really about deployed assets, discover what assets are deployed, discover how they connect together, and understand where you have inherent risk. And then proactively remediate based upon the most critical risk from that definition that we talked about. From there, you can shift left. So I've achieved where I've got really a strong automated understanding of risk out within my production environment. I prioritize remediation effectively. Now I want to shift left, which means I want to be able to focus within code. And this is preventative risk management, preventative security. I want to build secure by design with guardrails to really improve my software security supply chain. And hopefully I can continuously improve my security at the source by scanning within the actual developer environment, having checks within the CI/CD pipeline to prevent the introduction of those risks in the first place. Now, Zero Trust is always about understanding that, hey, we want to build as securely as possible, but that we assume that a breach could happen. And that assumption gets lost on a lot of people. Breaches will and you can and will happen in a zero trust environment. So we need to make sure that we also have reactive risk management, reactive security. And that means taking the kind of events that we've learned from our proactive and preventative security, taking that context and being able to enrich the data that we're receiving from a reactive perspective within our SOC. So then our SOC isn't just, hey, how many alerts can you reduce in a week? That's what we're going to measure you by. Oh, by the way, attackers actually know this, so they like to install things very, very noisy as they go and do their real attack, which is a lot quieter. Instead, it's how have you had an impact upon the most critical areas that need to be addressed? That's a reshift in the way that you think, while giving the information that you need to be able to do root cause analysis, to be able to understand blast radius, to be able to understand where the kill chain is so that they can do their job more effectively. When you put all these together, what we really see is this kind of like reverse funnel effect, where the majority of issues are identified early and are remediated and blocked within code, within our application security posture management. And then what does slip through or new things that get identified within the actual production environment are able to be prioritized and remediated effectively, while at the same time we are looking at the external attack surface, enriching our runtime remediation response from that SOC perspective, from that incident response perspective. So very quickly, how this can operate is you want to come at this from a cloud-native application protection platform perspective, or cloud native APIs, where you'll be able to identify all the different elements and how they connect together, right? So we have our networking, our workload, identity layers, and we understand the relationships, where it's not just, hey, I look at the configuration. That's all I would see from an agent-based deployment, where I'm only connected to one database, but instead my virtual machine, by nature of having connection to this other credential, is actually able to connect over to two different databases. Then I want to enrich with different indicators of risk, misconfigurations, exposed secrets, vulnerabilities, et cetera. And it allows me to be able to go back and say, hey, I need you to fix this vulnerability in this VM. Yes, I know it's only configured to go over this one database, but the reality is that there is a lateral movement risk that exposes a different database that you're not responsible for, that would expose sensitive information. That's why we're asking you to fix this first. That's how we build back in that foundational agility that was at the heart of Zero Trust in the first place, how we get the visibility into the environment, how we're able to prioritize and reduce the alert fatigue that's been plaguing our security teams, and how we can actually integrate security across, because then it becomes, hey, I can develop faster because I'm developing against the same measure of security that it'll be held up to once it's actually deployed. Hey, I'm able to remediate new threats and eliminate noise faster because I'm doing it with that cloud context. So that's all the time that I have. Thank you so much. I hope this has been helpful for you. I hope it's something that you've been able to take away a different perspective and really understand that Zero Trust at its heart is just a way of going and prioritizing your risk assessment so that you can hopefully, functionally, across your organization, reduce that attack surface profile.